We've got a diver leaping off the edge of a 20-meter high cliff, and we're trying to figure out what initial horizontal velocity he has to leap off at so that he just clears this 4-meter set of rocks extending from the base of the cliff. Now, once again, we'll set up our problem both in the X and in the Y direction independently. So let's set up our horizontal and our vertical and see where this leads. So horizontally, I call the X direction. And in that direction, you'll recall there is no acceleration. Your velocity is constant. So we only have the three variables: dx, vx, and time. Now, vertically, which I call the Y direction, it is accelerating. It's accelerating at negative 9.8 meters per second squared. So we're going to write down all 5 of our kinematic variables: v initial vertically, v initial y, v final in the y, acceleration, time, and total displacement in the y. Now remember, all of these things with the exception of time are vectors, so we have to watch our signs. Now if we go to the left-hand side, we can start filling in our known values. Now we know overall his horizontal distance has to be at least 4 meters. Now, if you look at my diagram, it would be to the left, and we could say that's negative 4 meters as my displacement. But don't forget, it's pretty arbitrary which way this diver is jumping off the cliff, so I'm just going to leave it as positive. Vx is what we're looking for. What is the horizontal velocity? Time we don't know for now. Now let's switch to the y. Now we know the acceleration in the y. It's always negative 9.8, which is our gravitational field strength on the surface of the Earth. We don't know how long it takes for him to hit the water below, but we do know his overall vertical displacement. He's going to drop 20 meters. So I can't say my displacement is 20. I can say it's negative 20, however. Displacement is a vector, and because I'm falling below where I started, I'm saying it's negative. Now, the trick to this question is your initial velocity. Remember, initially he's coming off the cliff completely flat. So he's leaping off this cliff in a horizontal fashion like that. And if you're leaping off completely flat, there is no initial vertical velocity. So your initial velocity in the y direction is 0 meters per second, and I don't know the final. Now, if I look at this list of information in the y and I want to solve for t, I'll avoid equations with v final in it. And the one equation that stands out is this one. Displacement is VOT, v initial times time, plus 1/2 AT squared. Now I have to stay within this column when I plug my variables in. My initial velocity in the y is 0. Now 0 times anything is gone, so I might as well just get rid of that right away. And now we'll plug in the rest of our values. My vertical displacement is negative 20 equals 1/2 negative 9.8 meters per second squared times t squared. Now I can get rid of the negatives. So on the left I get negative 20. 1/2 of negative 9.8 is negative 4.9 squared. Divide both sides by negative 4.9. And here's where I get rid of the negatives. And then take a square root. And at the end of the day, whatever 20 divided by 4.9, when I take the square root, I end up getting a time to hit the water to be 2.02 seconds. So now we know what t is. And I can take that time and transfer it across to my horizontal side. So if it takes 2.02 seconds to hit the ground, then I'm traveling horizontally for 2.02 seconds as well. Now staying within the horizontal side, a little easier, I only have one equation. My constant velocity equation, d is equal to vt. Now we know our displacement, 4.0 meters. We're trying to find out what vx is, and our time is 2.02 seconds. And when I solve all of that, I get a vx, a horizontal velocity component, of 1.98 meters per second.